We first need to start with a definition of temperature. So temperature is defined as the measure of the average kinetic energy of the molecules in a sample. So if we were to plot the fraction of molecules versus the kinetic energy, what we would see is we get a distribution of kinetic energies for molecules within a reaction. So there's a wide distribution of kinetic energies, and the area under this graph, so if we're looking at the blue graph here, all this area under the graph is directly related to the number of particles present. So if we were to figure that out, that'd be a specific number of particles. So what it does is it tells us what fraction of molecules we have that have specific kinetic energies. Now, at a higher temperature, there is a wider distribution of kinetic energies. Okay, so that would be our red curve here. It ends up being shifted slightly to the right and ends up flattening down a little bit, so it gets a little bit shorter and gets a little bit wider. But the area under the curve, so under this red curve here, is still exactly the same as the area under the blue curve. Okay, so we said this, as the temperature increases, the curve flattens and it broadens. So at higher temperatures, there is a larger population of molecules that have higher energy. Now, if we're looking at one of these distributions, we know that for chemical reactions to occur, we need to have a specific minimum energy, and that is our activation energy. So because molecules at higher temperatures, they're more likely to, or we have a larger population of molecules that have higher energy, then if we look at just the area under the curve for the two graphs above the activation energy, then the one at higher temperature has more particles that are above the activation energy than the ones at the lower temperature. All right, so we've said this. If the dotted line, so this dotted line here, represents the activation energy, then as temperature increases, so does the fraction of molecules that can overcome the activation energy barrier. So as a result, if we have more molecules that can overcome this barrier, the reaction rate is going to increase. So we can actually calculate the fraction of molecules using this expression here. So the fraction of molecules, so F is for the fraction of molecules, is equal to E to the negative EA over RT, where EA is our activation energy, R is our gas constant, and T is the temperature in Kelvin.